Nvidia AI GPUs are in huge demand in China. One vendor claimed he was able to source Nvidia's A100 GPU and charged $17,709, which is above its suggested retail price of about $10,000. Recently, with the support of deep learning, high-performance computing, large model training and other technologies, the era of general artificial intelligence is coming. All manufacturers are also working hard on the layout. For example, Nvidia recently released that the GH200 contains 36 NVLink switches, connecting 256 GH200 Grace Hopper chips and 144 terabytes of shared memory into one unit. In addition, Nvidia A100, A800, H100 and V100 are also popular in large model training. The memory of the AMD MI300X is far more than the 120 GB Nvidia GPU must chip H100, up to 192 GB. Globally, the competition of Nvidia GPU is very fierce. However, overseas giants have been purchasing GPUs relatively early and in larger quantities, and their investments in recent years have also been relatively continuous. The demand and investment actions for GPUs by large Chinese companies are more urgent than those of overseas giants. Take Baidu as an example. This year, the number of GPU orders placed with Nvidia reached tens of thousands. Although Baidu's scale is much smaller, its revenue last year was only 123.6 billion yuan, equivalent to 6% of Google's. However, this demonstrates the rapid development and huge demand of Chinese large companies in the GPU field. It is understood that Byte, Tencent, Alibaba, and Baidu are the most invested AI and cloud computing technology companies in China. In the past, they accumulated tens of thousands of A100 GPUs. Among them, Byte has the most allowable A100 Snow. Excluding new orders this year, Byte has nearly 100,000 A100 units in the previous generation product V100. The growing company Shangtang also claims to have deployed 27,000 GPUs in its L-Big device computing cluster, including 10,000 A100. Even the seemingly unrelated quantitative investment company Magic Fong has purchased 10,000 A100. From the total number, it seems that these GPUs are sufficient for companies to train large models. According to the case on Nvidia's official website, OpenAI used 10,000 V100 when training GPT-3 with 175 billion parameters, but the training time was not disclosed. According to Nvidia's estimation, if the A100 is used to train GPT-3, 1024 A100s will be needed for 1 month's training, and the performance of the A100 is 4.3 times higher than that of the V100. Large Chinese companies used to purchase a large number of GPUs mainly to support existing businesses or sell them on cloud computing platforms, and cannot freely use them to develop large models or meet customer needs for large models. This also explains the significant differences in computing resource estimation among Chinese AI practitioners. Yiqin Zhang, president of Tsinghua Intelligent Industry Research Institute, said when attending the Tsinghua Forum at the end of April, if you add up China's computing power, it is equivalent to 500,000 A100 pieces. You can easily train 5 models. In an interview with Caixin, Inga, CEO of Megvii, said that the total number of A100 available for large-scale model training in China is only about 40,000. This reflects the order of magnitude gap in computing resources between large Chinese and foreign companies, including fixed assets investment in film, servers, and data centers. Baidu, which first started testing ChatGPT products, has had annual capital expenditures of between $800 million and $2 billion in the past few years, Alibaba between $6 billion and $8 billion, and Tencent between $7 billion and $11 billion. At the same time, the annual capital expenditure of the self-built data centers of 4 science and technology in the United States companies, Amazon, Meta, Google, and Microsoft, also exceeded $2 for 150 people. During the past 3 years of the pandemic, the capital expenditure of overseas companies has continued to grow. Amazon's capital expenditure last year reached $58 billion, Meta and Google's were $31.4 billion, and Microsoft's were close to $24 billion. The investment of Chinese companies began to shrink after 2021. Tencent and Baidu's capital expenditure decreased by over 25% year-on-year last year. If Chinese companies want to invest in large models and earn more profits in the long term, they need to continuously increase GPU resources. Just like OpenAI, they face the challenge of insufficient GPUs. OpenAI CEO Sam Altman stated during a conversation with developers that due to insufficient GPUs, their API services are not stable enough and their speed is not fast enough. Before obtaining more GPUs, the multimodal capability of GPT-4 cannot meet the needs of each user. Similarly, Microsoft is facing similar problems. Microsoft is closely cooperating with OpenAI, and their new version of Bing has slowed down in response speed due to GPU supply not keeping up with the growth rate of users. Microsoft Office 365 Copilot has integrated the capability of large-scale models, but it has not yet been widely opened, with only over 600 companies trying it out. Considering the global number of nearly 300 million Office 365 users, large Chinese companies need to reserve more GPU resources in advance if they want to use large models to create more services and support other customers to train more large models on the cloud. At present, in terms of our large-scale model training, there are almost no substitute products for A100, H100, and their specially tailored versions A800 and H800 for the Chinese market. According to the estimation of quantitative hedge fund Kabine Investments, by 2022, Nvidia will occupy 88% of the GPU market in the data center, while AMD and Intel will share the rest of the market share. The current incompatibility of Nvidia GPU stems from the training mechanism of the big model, of which committed steps include pre-training and fine-tuning. Pre-training is to lay the foundation for the model, which is equivalent to receiving liberal education until college graduation. Fine-tuning is to optimize the model to adapt to specific scenarios and tasks, and improve its performance. The pre-training stage requires a large amount of computing resources, which has very high requirements for the performance of a single GPU and the data transmission ability between multiple cards. Currently, only A100 and H100 can provide the efficient computing power required for pre-training, which, although expensive, is actually the most economical choice. In the early stages of AI commercial applications, costs directly affect the availability of services. In the past, some models, such as VGG16, could recognize cats as cats with only 130 million references. At that time, some companies used consumer-grade graphics cards, such as the RTX series, to run L models. However, with the release of large-scale models such as GPT-3, the parameter scale has reached 175 billion. Due to the huge computational resources required for large models, using more low-performing GPUs to combine computing power is no longer feasible. When using multiple GPUs for training, it is necessary to transmit data and synchronize parameter information between chips, which results in some GPUs being idle and unable to fully utilize their working capabilities. Therefore, the more GPUs with lower performance are used, the greater the loss of computing power. When OpenAI uses 10,000 V100 GPUs for GPT-3 training, the utilization rate of computing power is less than 50%. The A100 and H100 have both single-card high computing power and high bandwidth capabilities to enhance data transmission between cards. The A100's FP32 has a computing power of 19.5 teraflops. 1 teraflops is equivalent to performing 1 trillion floating point operations per second, while the H100's FP32 has a higher computing power of 134 teraflops, which is about 4 times that of its competitor AMD MI250. A100 and H100 also provide efficient data transmission capabilities to minimize idle computing power. Nvidia's exclusive secret is the NVLink, NVSwitch, and other communication protocol technologies launched since 2014. The 4th generation NVLink used on H100 can increase the bidirectional communication bandwidth of GPUs within the same server to 900 GB per second, transmitting 900 GB of data per second, which is more than 7 times that of the latest generation PCIe, a peer-to-peer high-speed serial transmission standard. Last year, the United States Department of Commerce's export regulations on GPUs mainly restricted computing power and bandwidth. The upper limit of computing power was 4,800 TOPS, and the upper limit of bandwidth was 600 GB per second. The computing power of A800 and H800 is comparable to the original version, but the bandwidth has been reduced. The bandwidth of A800 has decreased from 600 per second of A100 to 400 GB per second. The specific parameters of H800 have not been disclosed yet, and it is reported that its bandwidth is only about half of H100, 900 GB per second. When performing the same L task, H800 may take 10% to 30% more time than H100. An AI engineer speculated that the training effect of H800 may not be as good as that of A100, but the price is higher. Nevertheless, the performance of A800 and H800 still exceeds that of similar products from other large companies and startups. Due to performance limitations and more specialized architectures, various companies' AL chips or GPU chips are mainly used for AI inference, making it difficult to perform pre-training tasks for large models. In short, ALVL creates models, while inference uses models, so training requires higher chip performance. In addition to the performance gap, Nvidia's greater competitive advantage lies in its software ecosystem. As early as 2006, Nvidia launched the computing platform CUDA, which is a parallel computing software engine that developers can use to train and reason AI more efficiently, fully leveraging the computing power of GPUs. Nowadays, CUDA has become the standard for AL infrastructure, and mainstream AL racks, libraries, and tools are developed based on CUDA. If other GPUs and AL chips want to connect to CUDA, they need to provide their own adaptation software, but they can only achieve partial CUDA performance and the update iteration speed is slow. Some AL frameworks such as PyTorch are attempting to break the software ecosystem monopoly of CUDA and provide more software features to support GPUs from other vendors, but their appeal to developers is limited. An AL practitioner mentioned that his company had considered using a non-Nvidia GPU manufacturer, who offered lower prices for filming and services and promised more timely support. However, they ultimately concluded that using other GPUs would result in higher overall training and development costs than using Nvidia, and would also have to bear the uncertainty of the results and spend more time. Although the price of A100 is high, it is actually the most economical to use, he said. For large technology companies and leading startups that are interested in seizing large-scale model opportunities, money is usually not a problem, and time is the most precious resource. In the short term, the only factor that may affect the sales of Nvidia data center GPUs may be the production capacity of TSMC. The H100/800 and A100/800 chips both use TSMC's 4nm and 7nm processes. According to Taiwan media reports, this year Nvidia added 10,000 pieces of data center GPU orders to TSMC, and issued an ultra-urgent delivery, which can reduce the production time by up to 50%. Normally, it takes several months for TSMC to produce A100 chips. The current production bottleneck mainly lies in the insufficient capacity of advanced packaging, with a gap of 10% to 20%. The production capacity needs to be gradually increased, which may take 3 to 6 months. Since the introduction of GPUs suitable for parallel computing into the field of deep learning, hardware and software have been driving the development of AL. The computing power of GPUs and the development of models and algorithms mutually promote each other. The development of models drives an increase in demand for computing power, which makes large-scale training that was originally difficult to achieve possible. In the wave of deep learning craze, China's AL software capabilities are already on par with the world's cutting-edge level. The current challenge lies in calculating the amount of time that can be accumulated, which involves complex supply chains and numerous patent barriers. Nvidia Large Model Training GPU Series Introduction. Since OpenAI released ChatGPT, generative artificial intelligence technology has been a hot trend that has received much attention. This technology requires powerful computing power to generate content such as text, images, and videos. In this context, computing power has become a prerequisite in the field of artificial intelligence, and Nvidia, as a chip giant, produces artificial intelligence chips that play a crucial role in it. Nvidia has successively launched V100, A100, H100 and other chips for all training. In order to meet American standards, it has launched A800 and H800, two bandwidth reduction products, for sale in the Chinese mainland market. The V100 is a high-performance computing and AI accelerator launched by Nvidia, which belongs to the Volta architecture family. It adopts the 16nm FinFET process and has 5,120 CUDA cores and 16GB to 32GB of HBM2 graphics memory. The V100 is also equipped with Tensor Cores accelerator, which can provide up to 120x improvement in deep learning performance. In addition, V100 supports NVLink technology to achieve high-speed GPU to GPU communication and accelerate the training speed of large-scale models. V100 is widely used in various large-scale AL training and reasoning scenarios, including natural language processing, computer vision, speech recognition and other fields. The A100 is a powerful data center GPU launched by Nvidia, which uses a new Ampere architecture. It has up to 6,912 CUDA cores and 40GB of high-speed HBM2 graphics memory. The A100 also includes second-generation NVLink technology, which enables fast GPU to GPU communication and improves the training speed of large models. In addition, A100 also supports the Tensor Cores accelerator independently developed by Nvidia, which can provide up to 20 times of deep learning performance improvement. A100 is widely used in various large-scale AI training and reasoning scenarios, including natural language processing, computer vision, speech recognition and other fields. In large model training, both V100 and A100 are very powerful GPUs. The following are their main differences and advantages. 1. Architecture. V100 and A100 differ in architecture. The V100 adopts the Volta architecture, while the A100 adopts the new Ampere architecture. Compared to the Volta architecture, the Ampere architecture has made some improvements, including better energy efficiency and a new tensor core accelerator design, which may allow the A100 to perform better in certain scenarios. 2. Computing power. The A100 is equipped with up to 6,912 CUDA cores, which is more than the 5,120 CUDA cores of the V100. This means that A100 can provide higher floating point operand per second, flops, and greater instance throughput, thus providing faster training speed when dealing with large models and data sets. 3. Storage tape-on. The memory bandwidth of the V100 is about 900 GB per second, while the memory bandwidth of the A100 has reached a higher 1,555 GB per second. High-speed memory bandwidth can reduce data transmission bottle bar and improve training efficiency. The A100 may perform better when dealing with large data sets. 4. Storage capacity. The V100 can have up to 32 GB of HBM2 graphics memory, while the A100 can have up to 80 GB of HBM2 graphics memory. Due to the fact that large models typically require more memory to store parameters and gradients, the larger memory capacity of A100 can provide better performance. 5. Communication performance. The A100 supports third-generation NVLink technology, enabling high-speed GPU to GPU communication and accelerating the speed of large model training. In addition, A100 also introduces the multi-instance GPU (MIG) feature, which can divide a single GPU into multiple independent instances, further improving resource utilization and performance. Overall, A100 may perform better than V100 in handling large models and datasets, but in practical applications, it is necessary to select the appropriate GPU based on specific scenarios and requirements.